And IPv4 addressing. Well, it's actually quite simple because you guys all know, right? The IP address is 32 bits long, like this. And the way we represent an IP address is more. Take 8 bits at a time, convert it from the binary form to the decimal form. And separate these 4 numbers by 3 dots. So, an IP address. And we actually say that, hey, each machine here is assigned an IP address. Yeah, it looks like it's indeed the case. Okay, but no, that's not quite precise. An IP address is actually associated with a interface. So each network interface requires an IP address. The tricky part is just this. Okay, a host here, okay, being at the end of the internet, at the edge of the internet, there's usually just one connectivity. Therefore, there's only one interface. Therefore, there's only one IP address. If you look here, routers being inside the core of the internet usually have multiple connections to the rest of the internet, therefore multiple interfaces. And you see here, a router can be assigned multiple IP addresses. All right? So routers typically have multiple interfaces while hosts typically one. Nowadays we do have 2. Okay, that is why the reason for that is because sometimes if we do have wire network access, then we can plug in to Ethernet, for example, conveniently. In case now, we can still use Wi-Fi. Okay? So regular hosts, we do have 2 physical interface cards, but we use it one at a time. Okay? So this is an end systems characteristic. Now the core systems router, definitely multiple interfaces. Okay. And you see a little bit more clearly that the interface is the part that connects a host, okay, to a link like this, to a link like this. Okay. So bottom line, IP addresses are associated with interfaces, not a physical machine. Now, yeah, we did not print any of the links here, right? We did not show any of the links there. Okay, so how these interfaces are interconnected through the links. And we'll talk about the links in chapters 6 and 7. So this is the wired link and this is the wireless link, like this. Okay, this is the wired link and a link layer protocol called the Ethernet. This one here is a wireless link. It's the Wi-Fi protocol. Something else about the IP address you should have a rough sense about is this. You might have seen that the machines nearby, okay, the IP addresses for their network interfaces might look alike, especially the first, few numbers. So 223.1.1 seem to be shared by these interfaces that are physically connected. Yes, those interfaces that are physically connected to each other belongs to a subnet. So the first few numbers there, okay, is called the subnet part of the IP address. And the last, okay, that are unique, so we could separate the different different interfaces is the host part. Those are the bits to the right, okay, the lower order bits. Now, only the interfaces that are physically connected, then they will share the same subnet address. Okay. So this is subnet 223.1.1. This is subnet 223.1.2, and this is 1.3. So each of them is a subnet, but these two are not in the same subnet because there's a router intervening. Now, we also use something like this to say, yeah, this is the subnet address. So subnet address. So you see here, this number is to indicate how long the subnet part of the IP address is. So 8 bits, 8 bits, 8 bits, 24 bits. Similarly, then the 223.1.2 subnet address is looking like this. And this is 1.3's subnet address. And what I'm teaching you here is there is an easier way to tell, okay, how many subnets we have here. Okay, because if you want to assign the subnet address, if you need to decide how long, okay, the subnet part of the IP address is, you do want to know, right, inside your network, how many subnets there are, and inside each subnet, how many machines there are, or how many network interfaces there are. To determine, okay, the number of subnets you have, you need to detach each interface from its host or router. Okay, as a result, it's going to create an island of these isolated networks. So let's detach host, 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 router, host, 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 host. So we get what? One island, okay, of these network interface cards. One island of these network interface cards. And another island of the network interface cards. So each isolated island is a subnet. So if you want to figure out how many subnet there is for this network, break all these hosts and routers. Okay. So interface, physically connected, we have one up there. So subnet 223.1.1. We do have another one here, these three, and another one here, these three. And guess what? Another one here, right? These two together form an isolated island. Another here and another here. So we together have 6 subnets here in this network. Until now, all these subnet addresses, we see this part being 24. But this is not quite true. Okay, to be more formal, the subnet part of the IP address can be arbitrary lengths. So the general format is looking more like this. Okay, the IP address on the left, and then an X, a number on the right. This indicates the number of bits in the subnet part. So in this example here, we do have the subnet part being 23 bits long. Say the blue part, only 23 of them. Therefore, the host part, we get 9 bits. So we could accommodate up to these many individual hosts. We could allocate these many individual IP addresses to these hosts. Now, if you have a subnet, okay, that has a number of machines, okay, higher than this, you will need more bits. So this guy here might need to turn black, okay, and we need to use a length of, for example, 22. Now, one last thing to talk about is this. How do we write the ABCD out? Okay, so this is how it works. Okay, take the IP address in the subnet, okay, and then convert them to binary form. Write it out. Okay, and then cut that IP address right at, okay, the part that's separating the subnet and the host part. So essentially, cut there right after the 23rd bit. Turn all the host part of the IP address into 0. Okay, and then convert this octet back to the decimal, this octet back to the decimal, the whole octet back to the decimal, and then the whole octet back to the decimal. Okay. So if you have an X here smaller than 24, then this last number here is always going to be 0, right? Because it's always cut earlier here. All these bits will be 0. Therefore, this is 0. Now, as to whether this is going to be 0, well, it depends on, the subnet part. It could happen that all these, the subnet part is also 0, then you have 0. Okay. Otherwise, you're just resetting only the host part to 0 in order to write the A, B, C, D out. And that takes us to an exercise.